gets hit by a bullet. So you could do whatever you want. You could get the enemy to attack the player faster, you could get them to just disappear immediately. You could do whatever you want. There's this update method, and this is called once for each frame. So every time there's a new frame drawn to screen, beforehand it calls this update method, and then you can do whatever you want in the scripting to move the enemies around and so forth. So just give you a bit of an overview of the C code. So I've got a number of data structures defined here. So I've got a struct for each bullet that stores the current position and the angle it's travelling in. I've got a list of bullets. I've got the definition for enemy objects that has the position and the size and so forth. I have an object for the player, so from the script you can access the player's X and Y position and the health and so forth. And I have an object for the display and an object from the level. Just going to turn power on, otherwise my laptop's going to die. So I've got a file called level.txt where you specify the structure of the level. And that's just a simple text file. It reads that in to create an array, which it then uses to draw the walls. So you can edit the level easily as well. Okay, so if we go into main.c, game.c, so it starts up, it does some initialization. This thing here is to do with the graphics initialization. So I won't go into too much detail about that. And I'll come back to the Python stuff later on. So it searches for, it initializes the player and the display. So it puts the player in this initial position, sets the initial angle to 0, which is going that way, and then it sets up the parameters to the display. So we have a loop here. So this while loop, this is the main loop for the game. So with the SDL library, what you do when you want to get input is you call SDL poll event, and then if there's an event that's occurred, then you can look at the structure of that event to determine whether a key's been pressed or the mouse has been moved or whatever. If that returns 0, then nothing's been pressed, and you just go straight on to draw the image. So if I look in the process key event, process key event, this basically says what key has been pressed, and then based on that it takes the appropriate action. So you can rotate left or right, or you can start moving forward. So this is all pretty much standard stuff that you would do in just about any game. And then after that it calls updates for all of the objects on screen. So the process of updating and moving an object is separated out from the process of drawing an object. So it first calculates the new position of everything, and then it draws it on screen. And I don't think you can bullet show up very well on that display. They do, the yellow ones do. But so your bullets are objects, and then enemies are objects, and so the position of these gets recalculated, and then it draws them on the screen. So I won't go into the details of those methods. They're all pretty much standard for what you would typically do. So now I'm going to talk about what you do when you're when you want to embed an interpreter. So what I've done is I've included in game.h I've included this Python header file, so that has definitions for all of the functions and data types I need. And when you compile your program, you also need to link it. So linking, when you link a program, and this is going to very much depend on your system setup, you have to specify what directories you want the compiler to look in for the include files, what directories you want the compiler to look in for the libraries, and you have to specify what library that you link it. So in this case, I'm using Python version 3.1, so I passed the -L Python 3.1 flag for GCC. I've also got a makefile for Linux here. So, as I mentioned, I'm going to put this code up on my site, and I'll send you guys a link to it, so you can take this and start modifying it yourself if you want. Okay, so I'm going to go into the guts of the Python binding code. Now, there's two main ways that I've integrated Python. One is that I've got two global functions that you can call from the script: add enemy and remove. Okay? And they are actually C functions. If I go to the actual implementation of those, add enemy is a C function. It takes two parameters, which are the X and Y positions of the enemy. And so if I want to pull that from the script, if I wanted, I could make it so every time an enemy dies, a new one appears in its old location, but slightly to the right. Say add enemy.x plus 100 enemy.y. And so now if I run that and I kill one of these enemies, then there should be another enemy over to the right. Now, that didn't happen because I've actually got an error there. And, okay, it's complaining about integer to float conversion. I'm not going to try and muck around with fixing that right now. But anyway, you get the idea. So you can set these, you can call these functions from there. But it's not just a simple matter of this function being directly called from Python. What we need to do is we need to write a binding function which converts the data type from Python types to C types. So the way that an interpreter works is that it has its own object heap, its own collection of objects. And they're separate from the objects which you normally deal with in C. So if I go to the code that gets executed when you call add enemy, this is the wrapper function which implements the binding. So every Python interface function that you define in C, it takes a parameter which is the object on which it was called, and it takes another Python object which is the arguments. Now you might say, well, what happens if you've got multiple arguments, but you've only got one arg object? So this is actually a tuple, and a tuple is basically just like a list of values. So what you do is you call this parse tuple, and that will extract the appropriate C values from the Python object. So you specify the type of arguments you're looking for, and then you also specify pointers to the variables in which you want to store those arguments. So if you've used scanf, it's a lot like that. So you do the conversion from Python types to C types, and then you call your actual real C function that does whatever that's supposed to do, and then you can return, if you want, you can return the result back to the Python. Now, in this particular case, the C function add enemy actually returns a Python object. If it returned a C object, we would have to convert that into Python. So if it returned an integer, for example, we would have to convert that from a C integer into a Python integer, and then return that. And then we've got this thing called incref, which means increment reference. And to explain what that means, I really need to draw a diagram of what objects look like inside the interpreter's menu. So you have your Python interpreter here. And then you have your program as a whole.